Let's consider now the curl. For the curl, we will need the Levi-Civita symbol, which you may or may not be familiar with. So let's do a brief primer on the Levi-Civita symbol. So the curl takes a slightly different form than the other vector transformations that we use. In components, this is what I have for the curl. V times W gives you this mixed components. That means that for each direction I, means each row of this vector, the components are of the form VJWK minus VKWJ with I different than JK. That means that if you are at the direction X, J and K are Y and Z. Well, but there are two terms here, and we need to specify which term is positive and which term is negative. So this is the purpose of the Levi-Civita symbol. It will take care of telling which is the positive term and which is the negative term in the curl. The Levi-Civita symbol is this epsilon ijk here. As you see, it has three indices, and it has these properties. So epsilon of ijk is equal to 1 if I, j, and k is 1, 2, and 3, or 2, 3, 1, or 3, 1, 2. This is called an even permutation. Imagine that you have here periodic boundaries, so you can shuffle them. You can put the tree from the last position to the first, keeping the same order. So that's what you'd have here in the end. So 3, 1, 2. You shuffle the tree back to the front, but you didn't change the order. The same thing here, 3, 2, 1. What you did is that you shuffled 1 to the end, right? And then pushed 2 to the front. It's an even permutation of the numbers. You do not change the order by which they appear. Now, the epsilon ijk, the Levi-Civita symbol, is minus 1 if ijk is equal to 1, 3, 2, 2, 1, 3, or 3, 2, 1. That means an odd permutation. You're shuffling here the order. You're flipping the order where the indices appear. You had 1, 2, 3. You're flipping the 3 and the 2. So the indices here are now not in monotonic order. And it is equal to 0 if I equal to j, or I equal k, or j equal k. That means if any of the indices repeat. Now, the Levi-Civita symbol is an example of a third-rank tensor because it has 3 elements. And manipulating the symbol requires keeping track of the permutations of the index. That means if the permutation is cyclic, also called even permutation, that means it does not swap the order of the indices. Periodically, the order is maintained. So that means that if the permutation is cyclic, you have 1, 2, 3. Again, consider that you have periodic boundaries here, so you can shuffle the 3 to the front. You have the 3, 1, 2. And now you can shuffle the 2 to the front, you have 2, 3, 1. So these are even or cyclic permutations. They do not swap the order of the indices. In this case, the sign is unchanged. That means that you can change the order here, I, j, k. You can put the k here. You can shuffle the k to the front, keeping the order, k, I, j. Or now you can shuffle the j to the front, keeping the order, that's j, k, I. And these 3 expressions are going to be equal. Now, if you have an anti-cyclic permutation, that means this one, that you keep that you flip the order, then the sign is going to change. For instance, you start with I, j, and k. Now, if you flip j and k, then you're doing an odd permutation. Say that you have I, j, k equal to 1, 2, and 3. If you flip k and j, you would have 1, 2, 3. So that's minus 1. You have to flip the sign. Again, if you flipped any other index, if you flip j and I, again, the sign would change. Or if you flip k and I, then the sign would also change. It's an odd permutation. Another property is that the Levi-Civita symbol is related to the Kronecker delta by this expression. It is the determinant of this matrix, where the coefficients are the Kronecker deltas. You can expand the determinant and find this expression here with several terms. Particularly important is when you have 2 of these indices here being repeated. Say that you have L equal to I, then you have the product of the Kronecker delta ijk times ijm, and you only have then the I equal to L. So these other 2 terms with Kronecker deltas will cancel out. You only have the first one because I and L is equal to each other. You only have what is inside here, the first parenthesis. That's called a contraction of the Levi-Civita symbol.